In the xy plane, a parabola has vertex 9, negative 14 and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y is equal to ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus b plus c? We're interested in finding the sum of the coefficients of this quadratic equation in standard form, but we're given the vertex. So let's start by writing this equation in vertex form, converting it to standard form, and then adding the coefficients. We start with y is equal to a times x minus 9 squared minus 14. We'll expand that out and then distribute the a. We want to know the sum of these three constants, so that's a minus 18a plus 81a minus 14. This simplifies to 64a minus 14. Now, at this point, you might say, wait, why is that helpful? 64a minus 14 could be anything. Well, hold on. The question also says that the parabola has two x-intercepts and a vertex below the x-axis. That means a must be positive. It follows then that 64a is greater than 0, and so 64a minus 14 is strictly greater than negative 14. The only answer choice that satisfies this inequality is D. The function f is defined by f of x is equal to ax squared plus bx plus c, where a, b, and c are constants. The graph of y is equal to f of x in the xy plane passes through the points 7, 0 and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? We're interested in finding the sum of the first two coefficients in this quadratic equation in standard form, but this time we're given x-intercepts instead of a vertex. So let's start by writing the equation in factored form, converting it to standard form, and then adding the first two coefficients. We start with y is equal to a times x minus 7 times x plus 3. We'll expand this out and then distribute the a. We want to know the sum of these first two constants, so that's a minus 4a, which simplifies to negative 3a. Again, that alone wouldn't be enough information if we didn't also have the statement that a is an integer greater than 1. It follows that negative 3a is less than negative 3, since we need to flip the inequality when multiplying by a negative. And so a plus b is strictly less than negative 3. The only answer choice that satisfies this inequality is A. The function f is defined by f of x is equal to ax squared plus bx plus c, where a, b, and c are constants, and a is between 1 and 4. The graph of y is equal to f of x in the xy plane passes through the points 11, 0 and negative 2, 0. If a is an integer, what could be the value of a plus b? We'll start by writing the equation in factored form. We then have y is equal to a times x minus 11 times x plus 2, and you know the drill. We'll expand this out and distribute the a. We want to know the sum of the first two constants, so that's a minus 9a, which is negative 8a. And this time, we're told that a is an integer between 1 and 4, so let's call it 2. That leaves us with negative 16. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex CD, which of the following is equal to D. We're given factored form, so the x-intercepts must be 2 and negative 4. The axis of symmetry of the parabola, which is the y-coordinate of the vertex, is halfway between the x-intercepts since all parabolas are symmetric. So we have that c is equal to negative 1. We plug that into the equation to get that the y-coordinate of the vertex d is equal to negative 9a. You also could have done this using Desmos. We would just toss our equation in, set up a slider, and say that a is 1. Then we have our vertex, negative 1 comma negative 9. Since little a is 1, the only answer that matches is answer choice A. Now, I've actually glossed over a critical piece of reasoning here, both for this solution method and for the digital SAT in general. The correct answer must work for any non-zero value of a, which means we have the freedom to choose a particular value of a to simplify our calculation. In the given quadratic function, a and c are constants. The graph of y is equal to f of x in the xy plane is a parabola that opens upward and has a vertex at the point hk, where h and k are constants. If k is less than 0 and f of negative 9 is equal to f of 3, which of the following must be true? The key insight here is that parabolas are symmetric, which means that If f of negative 9 is equal to f of 3, then the axis of symmetry must be halfway between those x values. Make sure this reasoning lands with you because you can't Desmos your way out of this one. To be clear, I'm demonstrating the concept using Desmos, but I needed the reasoning about the axis of symmetry to create the animation in the first place. So we have that the axis of symmetry is negative 3. We also know that the axis of symmetry is negative b over 2a. Putting those together, we get that a is 2/3. Next, we can plug the x-coordinate of the vertex into the function to find the y-coordinate of the vertex, k, and we're told that k is negative. That leaves us with 6 minus 12 plus c is less than 0, so c is less than 6. Let's look over our answer options now. Does c have to be negative? No, it just has to be less than 6. Is a at least 1? No, a is 2/3, so the answer is D. In the given equation, c is a constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? Let's go ahead and try Desmos here. I want to fumble through this in real time just to give you a sense of how tricky it is. Let's enter our equation in: x squared minus 34x plus c is equal to 0. Okay, I get an error message. I had to hit that slider first, so let's get our slider. C equals 0. Okay, mess with the slider. Let's see if this is easy. No, it's not easy. Okay, I'll give myself a y to make this a little clearer, make it a parabola. I don't know why I thought the same slider would work this time. Let's expand that range, maybe negative 100 to 100. Okay, here goes. Does that work? No, it doesn't work. The 100 was getting close, though, so let's just call it 1,000. That ought to hit it. All right, here goes. Okay, promising. 290 is close. Okay, let's back it up 1, maybe? 289? Hey, all right, that's looking promising. There we go, and that's it. That took me more than a minute, so let's compare that to doing this by hand. We know there are no real solutions. That means the discriminant of the quadratic formula is negative, and so we have negative 34 squared minus 4c is less than 0. We'll add 4c to each side. That leaves us with c is greater than 289, which means n is 289. Desmos is a powerful tool, but it's not always fastest, so don't be afraid to lead with algebra if it feels right. The function g is defined by g of x is equal to x plus 14 times t minus x, where t is a constant. In the xy plane, the graph of y is equal to g of x passes through the point 24, 0. What is the value of g of 0? 24 is an x-intercept, which means either x minus 24 or 24 minus x must be a factor of g, so t is 24. That makes g of 0 14 times 24, which is 336. In the given equation, p is a positive constant. The sum of the solutions to the equation is 20 over 3. What is the value of p? Let's toss this into Desmos and hope for the best. We'll give ourselves a y to make this look like a function, and so that our x-intercepts come up as gray dots. But then we realize that we need these 5 intercepts to add up to about 6.67. We could play a guess and check game with this slider, but that seems tedious and risky. I would bail on graphing at this point and try the old-fashioned way. The first parentheses will generate one solution. 3x plus p is equal to 0, so x is equal to negative p over 3, 1 down. Next, 5x squared minus 45 is equal to 0. We'll pull out the 5, split up the difference of squares, and we get that x is 3 and negative 3. Finally, 2x squared minus 16x plus 6p is 0. We pull out the 2, and we can't factor this because of that p, so let's toss it in the quadratic formula. Ugly as this looks, good things happen when we add the solutions of the quadratic formula, so stay with me. The sum of our 5 solutions is then negative p over 3 plus 3 minus 3, and these radicals also cancel, so the sum of the last 2 solutions is just 8. That leaves us with 20 over 3 is equal to negative p over 3 plus 8, and we've got this one on the run now. Subtract the 8, negative p over 3 is equal to negative 4 over 3, so p is 4. The graph of y is equal to 2x squared plus bx plus c is shown, where b and c are constants. What is the value of bc? Looking at the graph, we see that the axis of symmetry is at negative 1, and we know that that must also equal negative b over 2a, so negative 1 is equal to negative b over 2 times 2. That gives us a b of 4. C is just a y-intercept, so that's negative 6. We multiply those to get negative 24. Subscribe to the channel and check out my next video on polynomials.